Our next speaker is dash.js chair, also chief architect from Akamai. You'll love. You probably know him from a lot of different events. He's going to talk about the open source dash.js JavaScript player. Thank you.
Right, thank you. Good afternoon and welcome, as Yasa said, to the session that needs coffee, but I think it's the more interesting session of the day, which is the player side. It's interesting to me that in conferences, the players get relegated to the second half of the second day, which is not exactly prime time. And also in our corporate thinking, players are sort of an add-on. People spend a fortune on context-aware encoding and fancy multi-CDN and distribution protocols, and then you put a bad player on top of that, and it's like a bulldozer that just destroys your client experience. So, word of warning, take players very seriously. They are the intelligent component in adaptive streaming, and there's an awful lot of complexity that goes into them, and a poorly implemented player can damage a lot of good work done by other people. I actually gave a number of topics to Ali to speak on. They were not connected to each other. And he said, hey, great, you can talk on two of them. But surprise, you only get one session to do it in. So I actually have two presentations today in only 20 minutes. So the first one is about dash.js. Second one is about standardizing QoE metrics. I'm going to go quickly through both of them. So if you're not a millennial, I notice most of us are not. You'll remember compiled players from early 2000. They looked like that. And then HTML came out very simply. It did progressive video. And it was a very simple API, and everybody could use it. But if you fast forward today to YouTube and Netflix, you notice we have far more sophisticated HTML5 players. So what was the magic that got us from that rectangle to the ones on the right? And that was basically MSE. And its name's popped up in multiple presentations. I'm not going through it today. Media source and its encrypted equivalent, EME. So back in 2012, which is when those were in a draft status, we looked at the new MSE API, and after coming out of 4 years of writing ActionScript libraries to help people play RTMP, we said, there's going to be some complexity to this. You have to manage scheduling and queuing and DRM and a lot of complexity. And at the same time, Dash came out, and it was also complex. You put the two together, and you have a very complex environment to address with. So we decided to make an open source project that would enable you to play Dash through the new APIs. We called it dash.js. Luckily, Git remembers everything. I went back, and here was our very first submission back in November of 2012. So this project is almost 5.5, almost 6 years old to this day. Luckily, the next few thousand submissions were not me, which is good for the project because there's better developers than myself. But that's when we started. And at the same time, the Dash Industry Forum was looking for a reference player to play back Dash. And they went out quite admirably, in my mind, and took a bet on JavaScript, which was still dicey at that stage. We could have gone with a C player or a C or a Java reference platform. They decided to go with JavaScript just because of its accessibility. Anybody can get a text file, look at the code, and see how to play back Dash. And I think that bet has paid off as well. So fast forward 6 years, it's a thriving project today. We have 146 different committers as of the last release. Typically 3 to 10 are involved in each release going out. Several thousand issues have been raised and closed to date. We've got several hundred still open. Several thousand PRs have been merged into the project. We're on a fixed 5-week cycle now, 4 weeks of dev, 1 week of test. We've got a good cohort of people in our email list for addressing problems. And we've got a full-time admin on the project to help coerce it, because open source projects at many times are herding cats. So we have a full-time cat herder. This is our commit history for the last 5 years. So you can see we're actually doing a lot of work now. We haven't slackened off. It wasn't early work done later on. We're getting quite aggressive with the project. Interestingly enough, this is our NPM downloads. So I have no idea who downloads it from Git. We don't track that. But on NPM now, we're hitting 20,000 downloads a month, which is quite a lot for a Dash player. So we're getting really good penetration and usage there. We don't have any tracking built into the framework, so I don't have a clear idea on who's using it and who's not. So if you certainly are, we're very interested in getting feedback in that regard. But NPM is certainly pointing at an awful lot of activity. So the technology itself, it's a JavaScript client. It's written in ES6. It's then transpiled and minified out to ES5 for distribution and compatibility with a broader browser base. make use of EME and MSE. Of course, we do adaptive playback with Dash. We've extended it. We have an optional component to do smooth support. You might say, well, why is a Dash player playing smooth? But thanks to Microsoft, smooth is clearly an evolutionary path to Dash. There were a lot of people who wanted to migrate smooth playback to Dash playback, and it was relatively simple to add on smooth playback to the library and have it in there, so it's there. We have all this requesting, the buffering, the switching logic you would expect in a player. It's essentially a headless library. So it's the full logic for passing MPDs, requesting, doing bitrate adaptation. You pair it with a video element that your application provides, and then you get a player. And then you're going to dress that player up with either your own UI or build it into a more sophisticated application. We do provide a default UI element because the scrub bar that comes with a standard player is mediocre at best for VOD, and it's miserable for live. You know, you can't do live seek with a default scrub bar, so we do provide that side of it. And of course, the client's compatible where MSE is supported today, which is almost everywhere, with the sole exception being iOS Safari. So that would have been my question for Apple this morning had it got to me is, come on, the rest of the industry is supporting this. Safari supports it on desktop, but Safari on iOS does not. So outside of Safari on iOS, we have good support. We have a lot of features in there. I'm not going to list all of them right now, but the ones that I think are interesting for the industry are captioning. We have good, robust captioning support. IMSC1 is in there right now. It's what I hope is going to be the converged standard for captioning. We do support other flavors of TTML, 608, 708 as well, and WebVTT. DRM is also one of the more complex sides of player playback today. We have clear key support, we have multi-key support, and persistent licenses. And a lot of our current thrash around changes and issues always involves DRM. There's a lot of perturbation in that solution. For playback, we've got now smooth period transition, so no gap transitioning from one period to another by examining the codec we're coming from to the codec we're switching to and deciding if we can reuse the source buffer. Jumping gaps feature, this is a part of real life. Segments don't line up neatly, even though they should in the world. Buffer management, ABR algorithms is in there. EMSG support we've had for a while. Extracting EMSG events, dispatching them up to the application layer. Seek robustness, preload, if you want to load your content, have it start instantly. Improved smooth support. Thumbnail was something we invented a solution at dash.js. It worked reasonably well. We deployed in dash.js, and it's there. So it is a simple and easy way to generate thumbnails for your content, so check that out. We've got multi-track support, both for video and audio. That's multiple adaptation sets on the same piece of content. And then also multi-period support. And it's multi-period support that's probably the weakest part of any Dash player and the hardest to get right, because you're juggling virtual timelines all the time. We did add a default control bar UI. You don't have to use it, but it's there if you want to use it. And a lot of the work in the last 2 sprints has been around low latency, chunked encoded, chunk transfer of CMAF. So Dash.js today will get you in the 2 to 3 second range, as long as you supply it with the right Dash stream. And I think this is really a harbinger of what we've discussed today. I know Cost Labs is doing work. I know TheoPlayer does work around this, and certainly Dash.js. We'll probably hear from Shaka Player as well. There's a lot of activity and movement around to reducing latency to the well below broadcast levels, in fact. So it could be that when you're watching the soccer game, everyone will move to the OTT instead of staying with the broadcast. The license for those interested is BSD3. It's a very permissive license. You can basically do almost what you like, sell it, modify it, distribute it, put warranties on it, as long as you include the copyright and include the license with the code that you distribute. So we do provide a reference player for the Dash Industry Forum. This is a player that attempts to implement all the features that are described in the Dash spec, and there are a lot of them. So we're not saying this is a player you put in front of end users. This is a player designed to test playback. So it comes with a graph and charting function built in. You've got a lot of attributes and statistics and metrics that you're looking at in real time, and if you pull down the pull down here, you'll discover several hundred sample streams that you can look at, including the full set of the Dash.if test vectors that are pulled in dynamically into this player. It's responsive, so if you look at it on a tablet or a phone, you're going to get something that's still visible. Don't forget to look at the options panel. It's kind of hidden, but it gives you a lot of settings you can change onto it. It's where you put your DRM keys in if you want. initial settings like do you prefer French or German or English, for pre-selection, track switch modes, and also the debug. So there's an awful lot of control panel logging that goes on. So if you want to see why your player stopped for a reason, definitely go check for the debug statements. Now let's go back. That's just the reference player. Of course, as I said, it's headless. So you basically build your own player here. So we have another sample site that's new. I know we had bad samples for a while, but they've recently improved. So now under getting started, there's very simple examples on how to embed it into a web page, also doing smooth thumbnails, DRM, multi-period, captioning, ad insertion. Simply, and when you look at the sample, you get your block of video, and then you get just the code you need. So to embed this player, for example, you embed the library, one line of JavaScript, you just decorate your video element to say I want it to be a dash.js player, and you walk away. And that's the simplest embed that can be. And let's shut the audio off, but the Hello World application is, can you get more fancy? So this is dash.js mapped to 6 faces of a cube and spun around. And this is just a couple of lines of JavaScript. It's not fancy, but it shows you that we're not stuck in this world anymore of monolithic rectangular players. You have all the richness of CSS and HTML that you can bake into your player. Here are some key links, not for reading now, but for looking at after this presentation. So we do host minified versions of it on Akamai for everybody to use. So there's a reliable and fast download of the library itself. We host a lot of all the archived reference versions over the last 5 years. You can go back. And we maintain an NPM base as well. Dash.js is used a lot in the academic world. I know Ali will attest to this. 3 of the last 4 winners for the Excellence in Dash Awards all use Dash.js in their research. A lot of people are testing algorithms in it. And in fact, we've incorporated some of that research. You'll see the Bowler algorithm, buffer occupancy, is in there along with some of the new adaptation. And anyone who has a better adaptation algorithm, we're very eager to explore its usage. That's something that's close to our hearts. We also have a lot of commercial use, and people don't realize this. Dash.js player straddles 2 worlds. One is this -if reference world. The other is people depending on players to make money. So some large companies here use Dash.js. They didn't want me to release individual stats, but on aggregate, we're getting 21 million users per month, and many million hours per month played back through the library. So it's certainly in commercial use, and that is the intent of the project. How do you get features in? Well, you go and raise an issue on GitHub. It's public. Anybody can do it. These are all feature requests there. Some of them get higher priority. These are ones from -if, and our admin will execute those first. But other than that, it's essentially community voting. So you can pay a developer to expedite your particular feature, or go in and implement it yourself. A lot of features stacked up and queued there. This is Jesus. He's our lead admin based in Madrid right now. Excellent guy. And so when you see Epic Labs on Slack, he's the guy who's actually responding to you. And Dash.js is really a community of people. It's people deciding, I don't want to build a player all by myself in my cube all day. I want to share it with all the other people who are doing the same thing. So that is essentially the spirit of the project, is if everybody contributes 10% and 10 of us do it, we get a 100% project, and so far it's working. So you can participate, find us at GitHub, join the email list, join the Slack channel, and every year we have a face-to-face meeting in Berlin. And it's always a good activity with much social time afterwards as well. So that concludes halfway through my presentation, my first subject, which was Dash.js open source. I now launch into the second one, a little drier, so I apologize for that, but it's standardization of statistics from media players. And it is loosely coupled, because obviously Dash.js is a media player, but this is far broader. We're talking all the media players for OTT. So you may say, well, what is QoE? And there's a rather cool definition from ITU, which is quality of experience is the degree of delight or annoyance of the user at the application of service. So we're trying to quantify delight and annoyance. Yeah, I like that definition. How's it different from QoS? Well, QoS is it's the engineering and the behavior that causes the annoyance or the delight. So if we as a CDN are slow in delivering a segment, how slow we are is QoS. If that causes the player to rebuffer, that's how we would define QoE. So QoS affects and defines almost the QoE that's experienced by the end user. Now, there are many companies in the business of providing analytics services. Here are some of them. And many companies today distributing content will use multiple analytics providers. And the trouble is, if you get statistics from these providers from the same set of devices, are they in fact interchangeable and comparable? And in fact, today they're not. And I can give an example by this, by if I say, hey, the rebuffer ratio is 5%. And you may have a clear idea in your head what that means. But then answer these questions for me. Does this mean the average viewer spent 5% of their view time rebuffering? Or did 5% of reviewers have at least one rebuffer? Or was this a mean or median value? There's quite a difference there. How long do you have to rebuffer for it to be counted? Is a 1 millisecond rebuffer as counted as a 5,000 millisecond rebuffer? What about rebuffers that persist to the end of the session? In other words, the player is stuck in a rebuffering state. Do you count that? And for a live stream, is this rebuffer rate the last minute, the last 5 minutes, or since the stream began? And does it include users who have finished their sessions, or in the middle of their sessions, or have just begun their sessions? So there's an awful lot of ambiguity for something that seems on the surface to be relatively simple. So that's the first problem, ambiguity in the stats. The second one is player APIs. If you're in the player building business, you'll know that to do an integration with an analytics provider is often you get deep under the covers. The analytics provider wants certain events to be and properties to be dispatched, and this is different for different analytics provider, and it becomes a custom job to integrate these. So there's two main problems then. Inconsistent events and properties coming from the players, and then also inconsistent calculation and definition of the metrics once they've been retrieved from the players. So there's a horribly named group, R4WD20. It's not going to attract anyone to it. Set up by the CTA. Who are the CTA? Well, they're the renamed Consumer Electronic Association. So the group that brought you HDMI standard, for example, they have a vested interest in making sure that we can define consistent quality of experience on players. So we set up this project to try to do this, to define a set of device events and properties, and also define how we calculate the metrics. And it's not more complicated than that. We're trying to establish consistency between these. So who's involved? Here are some of the companies. Many are in the room today. I will point out Mux and Conviva specifically, and also Akamai are sort of the main providers here, but certainly everyone on this slide has contributed to the meeting so far. And we welcome more. This is not closed by any means. Initial input came from two sources. There was a document produced by the Streaming Video Alliance. I think Conviva brought it in there. That was contributed. And on the Dash side, we actually put a white paper together on how we proposed metrics for Dash players. And we decided that we don't need a silo of metrics for Dash players, another one for HLS. We want one set of metrics for everybody. So we took both of these as input, took it to the CTA, and are making a spec there. The operating model is relatively simple. It assumes there's a device with an OS. There's some application execution environment. It's got a media player. And then there's an analytics client that lives in the application environment next to the media player. And it talks to an external analytics server. And this client communicates with the player through events and properties. So this is a model that's matched both in HTML5 and also in Java and in iOS development as well. So we assume this architecture, and what we're doing is standardizing these events and properties, and then also how the analytics client takes this information and calculates the QoE metrics. There's a hierarchy to these. So on the media player side, we define properties and events. We are event-based. We don't want analytics clients polling for information. So we want the player to dispatch a change in state, and then the player can ask it for a property that should be updated at that time. Then we have standardized video view measurements. This is for the view is what one person plays back content, and then we define rules for how these are aggregated, because mostly people are interested in the aggregation more than individual sessions. And I'm not going to go into the details. This is some of the tables from the spec. There's items in there that you would fully expect to be in QoE. We are not inventing new metrics. So things like rebuffer rate is absolutely one of our stats, but we then answer those questions I supplied previously on how to define it. We also have added some state diagrams, and these are actually very useful if, as a player builder, you're trying to figure out when you should dispatch events. So here's the event I should dispatch, here's a content ID property, and here's the playback state of the media as I move through this. So it's one thing reading a dry spec. I certainly find it much easier to look at pictures. So we've recently introduced these, and there's not one of these, there's about 7 of these to explain different aspects of monitoring. The work is not complete. We're aiming for Q4 of this year. It's been 1.5 years underway. To participate, all you have to do is be a CTA member. I think most companies in this room are CTA members, so in fact, there's nothing stopping you from contributing. Conviva are chairing the group, and Mark Levine is the guy to get in touch with if you'd like to join. And that is my / presentation for both of those. So I'm happy to take questions on dash.js or QoE metrics. Joey has a question.
Hi. So, very selfish question. How good or bad an idea is it for some hypothetical other player to start implementing those QoE metrics right now before the spec is published?
It would be excellent if hypothetical said players started implementing them, because then hypothetical player could give feedback early on to say, this is crazy, this is difficult. So we have JW Player in the project. They've committed to do that. I've committed dash.js, but I would absolutely welcome a third party in there who knows what they're doing to give early feedback. So we're very open to that.
Great. I wish I had been earlier. Thanks.
Okay. Well, you will be contacted.
Other questions in the crowd? You seeing any, Will? So.
Nope. I don't see any. Okay, thank you very much.
Okay.